Hello, and thank you for joining me for the third data analysis bootcamp, getting into our first Hell Week, Pandas plotting function. These are really good plots. They are super quick and easy, and I find that I use Pandas plot, although maybe it's not the plot that I use the most for presentations. In my data analysis, my exploratory data analysis, I would say I use it about half the time, and maybe even Pandas a little bit more because it's so quick and easy to use. Before we get started, let's recap our mnemonics from the last class. Okay, so when we were talking about what a data analysis really does, okay, really what the rules are. So we talked about when we get started, we remember we were sitting down at our desk, and when we sit down at our desk, we want to decide where to go from here. Like what do we want to explore the most? Because there's so much in any data set, even a small data set, there's so much to explore. So we really start with understanding our distributions to help us understand where to go from here. What we're really trying to do is simplify our distributions usually to a summary statistic, right? We had that poster in front of our desk to help us remember that we wanted to get to the point of summarizing and understanding which or what type of distribution, the shape of our distribution is going to help us understand how there could potentially be a skewing or a misunderstanding, misinterpretation in this summary statistic. And we need to be aware of that when we're presenting our results. And if you remember, there's that bang, bang, bang noise coming from the room next to us, and that was them doing their hypothesis testing. Important step, kind of annoying being in the next office, in the office next to us, but the hypothesis testing is such an important step, and the shape of our distribution will enlighten how or let us know how we can best perform that hypothesis test. The last time we saw the moon, the full moon, I was outside of my apartment when I saw the moon the last time. And then remember from there, we were standing there and there was all this data coming down from the moon, raining down from the moon, which is a weird situation. So we kind of classified that. We decided to say, well, that's the situation that would be outlier data. And as we want to be careful of our distributions. Distributions will give us an idea how we would set that threshold of what is or is not an outlier. The data that was raining down was starting to skew our view, our understanding of the world around us. And so we have to be aware of the skew and the kurtosis in our distributions because that will affect the summary statistics and how we can interpret those. And like an exponential distribution, which has a lot of skew, or even just a normal distribution that's leaning one way or the other, will change what that summary statistic, the most appropriate summary statistic is. And we were also concerned, as the outlier data was raining down from the moon, how would it affect the relationship? Our relationship. Our friend was coming up to see us, and we couldn't really see him that well anymore. That's the same thing. Our data set, as we look for the relationships in our data set, we want to be concerned, maybe look for how things are related to each other, the skews, if we're seeing patterns between all of our distributions that will it's not a bivariate analysis in a true sense, but it will start to give hints of what we should be expecting to see as we get to the bivariate analysis. Not that you have to do the univariate analysis first, but that's usually typically where I would start. We talked about really what we're trying to do from our sample of data that we have. We're trying to make inferences on the population. And so although it looks like we might have a lot of data, we always have to keep in mind that we have just a small sample, and we really want to take that to heart because that is going to affect the robustness of any summary statistic we have, okay, in understanding the population. Talked about, and we'll get a lot more to this in later classes, but we talked a lot about the histogram plot and how important it is really to understand the data in by generalizing, getting rid of some of the noise, and really help us see the shape of our distribution by removing some of that. And we'll get into a lot more how the histogram plots, but it's really one of the fundamental, one of the starting plots that you usually typically do in univariate analysis. We talked about our different distributions. We talked about the distribution that's equally likely to or equally likely to occur, or every data point is roughly equally likely to occur, and that is the uniform distribution, just like our pythons wearing their nice uniforms, very all looking the same here, just like our uniform distribution. Talked about it. The distribution that has the symmetrical on both, that is symmetrical on both sides, or the ideal situation would be that it's symmetrical. There's the normal distribution, just like our symmetrical looking python here. We talked about time between events, and that is often occurring in financial data. It represented in financial data often, or other time series type data, we'll see this exponential distribution with a long rate tail. We a tricky one to use, and we'll come to how we can deal with those distributions. Another really important one is the categorical distribution, and we talk often about the balance, imbalanced or balance between the different classes in our category here, the white and black Python. Where's the balance between those classes in our distribution? We talked about how sometimes there's going to be things you don't understand in your data. They don't follow a normal sort of pattern in distributions. And we want to, instead of just racking our brains, we really want to talk to an expert in those situations and see really if they can guide our analysis and help us understand better what we're seeing and why we're seeing it. We talked about how when we're looking at a normal distribution, or really in any distribution, the outliers, like our outlier gentleman here, it will pull the mean towards it. And on a simple basis, if it's affecting the mean, it's going to affect a lot of other statistics in our analysis. So we just have to be aware of those outliers. It's amazing how much of an impact they have. So we have to be conscious of them. Depending on what we do them depends on the situation, but we need to be aware of what they are. It's just like he's pulling the moon and the mountain towards him. They're going to pull a lot of our summary statistics towards the outliers. Okay. Talked about ways to deal with an exponential distribution. Common ways would be to bucketize. We're going to change it into categories 1, 2, 3, 4, category A, B, C, instead of a medium, small, medium, and large, instead of having that long tail, and that will essentially remove the effect of that long tail. Another option is to do a log transformation. This is the one that I would say I typically do, in the sense that it now converts or attempts to convert our exponential into a normal distribution, which is kind of the ideal distribution we want, where the average is really right in the center of the distribution, really where the weight of the distribution is. We also talked about ways to define an outlier. And using the classical definition, we have our IQR range, which is the 25th percentile to the 75th percentile, and 1.5 times on the outside of that is our classic definition of an outlier. It's good to stick with that classic definition, because as we'll see in later classes, the way you manage and the way you handle your outliers will affect your summary statistics. And so straying too much from that without a good valid excuse raises the question of, were you doing that just to get the summary statistic you wanted to find, or did you truncate your outliers? Did you treat your outliers in a really common sense way that would make sense for this data set?